So the assignment related to acid-base equilibrium MCQs related to the topic. So first 20 MCQs are already recorded. So 21 onward. The first question 21. Which of these substances give a solution with the highest pH when equal amount are added to the same volume of water? So means which of them will make the solution alkaline, because we want the higher pH. So when we check the options, this is acid, ethanoic acid. So ethanoic acid, when it dissolves, it will, even though it partially ionized, but still the amount of hydrogen ion will increase. So the pH will be less than 7. So it can be A. Same thing, the second one, you can see acid group is there. It will also, even though it's a weak acid, but still the amount of hydrogen ion will increase slightly when it is added to water. So that it will lower the pH. What about CH3COONA? That's a salt of the acid which is produced, or a conjugate base, because for any acid there is a conjugate base. Like example, if this is an acid, it will dissociate into CH3, CO negative, and H positive. So this is an acid. This has a tendency to accept proton. So this one is a base, conjugate base. So same thing happened. This CH3COONA, sodium ethanoate. So when it will dissociate, it's a salt. So when it dissociates into water, dissolve in water, it will form CH3CO negative and Na positive. And this CH3CO, what is the tendency? It has a tendency to accept protons. So if there is a water molecule, which is H2O or HOH, so that will accept proton or take proton. As a result, it will produce CH3COH, a molecule. But the pH of a solution changes as the amount of hydrogen or hydroxide ion changes. So as this, it accepts protons, the amount of hydrogen ion decreases. So the pH of the solution will be higher, or amount of OH will be more. So that's why option C is a right answer. Why not D? That is ethynyl chloride. When it dissolves in water, it will form HCl, like CH3COCl plus H2O. As a result, OH will take position of this, so it will be CH3COOH plus HCl. And due to this HCl, amount of hydrogen will increase, so the pH will be lower. So the one which is having the highest pH, that is option C, which is sodium ethanoate. Is it clear, this one? Then next question. What is the pH of following solutions? We will take a dissociation constant, take Kw as 1 exponent minus 14, where necessary. We have a nitric acid. So first, a nitric acid, what is a nitric acid? It is HNO3. Nitric acid is a strong acid. Strong acids ionize completely, so the concentration of the acid is same as the concentration of the hydrogen ion in the solution, because almost all of the molecule dissociate into ion. So if I have 0.2 moles of nitric acid, what is the concentration of hydrogen ion? 0.2, and concentration of nitrate also 0.2. So we have the concentration of nitric acid. Using that, we can get the concentration of hydrogen ion, and the pH is equals to minus log of hydrogen ion. So we just have to substitute this 0.2 log of 0.2, that will give us 0.7. So D will be the right answer. The next one, 0.2 mole per dm cube barium hydroxide. So barium hydroxide, solubility of hydroxide increases as we go down the group. So how to solve such question? For a barium hydroxide, it will dissociate into what? It will dissociate into barium ion and 2 hydroxide ions. So means the concentration of like if we have one molecule of barium hydroxide, 2 moles of hydroxide will be formed. So the ratio, if this is 0.2, this will be 0.4. Why 0.4? Because the ratio between them is 1:2. After getting the concentration of hydrogen hydroxide ion, we know the dissociation constant is 1 exponent 14. So means the dissociation constant is always the concentration of hydrogen ion and the concentration of hydroxide ion, the products. The dissociation constant is 1 into 10 to the power minus 14. The hydrogen ion concentration, we don't know, and the hydrogen hydroxide concentration is 0.4. So this will be 1 into 10 to the power minus 14 divided by 0.4. This will give us amount of hydrogen ion. And using that hydrogen ion concentration, we'll now use the formula that pH is equals to minus log of hydrogen ion concentration. So when we substitute, this will be 13.6, or C will be the right answer. Is it clear, this part, the second part? So the important thing is you should identify like how many moles of either hydrogen ion or hydroxide ion produce when this reaction happen or occur. In part C, a mixture of 10 cm cube, 1 mole per dm cube hydrochloric acid and 20 cm cube 0.1 mole sodium hydroxide. So first what happened, because we are using excess of sodium hydroxide, so means this solution is, it should be alkaline, right? And what should be the pH first? We will identify, like we have hydrochloric acid and sodium hydroxide when they react with each other. So when sodium hydroxide react with hydrochloric acid, gives sodium chloride plus water. When we find the moles, moles is concentration into volume, 1 into 10 divided by 1000 into 1. Moles is concentration into volume. So that is 10, but volume should be in dm cube. So this is, the concentration is 0. The moles are 0.01 for HCl. And the moles of sodium hydroxide are 0.02 because volume is 20 and the concentration is 1. But the ratio between them according to balance equation, ratio is 1:1. So 1 react with 1, so 0.1 will react with 0.1. So HCl will the limiting reagent, so HCl will be used up. And if HCl is used up, how many moles of sodium hydroxide are left? So 0.2 minus 0.1, because that is the 0.01 that is reacted. So we are left with 0.01 moles of sodium hydroxide. Now, after having the moles of sodium hydroxide, we need a concentration. But now what is the concentration? Original concentration was 1. But what about new concentration? Because the total volume has changed. When you mix 10 cm cube with 20 cm cube, so now the total volume is 30 cm cube. So you should, to get the new concentration, the concentration is moles divided by volume. So moles are 0.01 and the volume is not 10 or volume is not 20, it's 30. Because the two solutions are mixed with each other. So it will be 30 divided by 1000. That is equivalent to 0.03. So when we solve 0.01 divided by 0.03, that is 0.33. That's the concentration of hydroxide ion. 0.333, the concentration of hydroxide. But to get the pH, to find the pH, what we need the total amount of hydrogen ion, because pH is equal to minus log of hydrogen. So then we'll take again the formula that dissociation constant of water is the amount of hydrogen ion and the amount of hydroxide ion. So dissociation constant at 25, which is 1 exponent minus 14. Hydrogen ion concentration we don't know in this sodium hydroxide. The concentration is 0.33. So when we simplify and find the pH, that will give us around 13.5, or A will be the right answer. So after getting the hydrogen ion, then we substitute in the formula of pH, which is equals to minus log of hydrogen ion concentration. So what we did, we work out how many moles of sodium hydroxide are left after reacting. Then we work out the new concentration as the total volume has changed. So the concentration definite moles are changing as well as the volume also changed. Like first it was 20 and then 10 cm cube of hydrochloric acid added, which makes it 30 cm cube. The concentration is moles divided by volume. So new moles divided by new volume will get the new concentration of hydroxide ion. Using the concentration of hydroxide ion, we find the concentration of hydrogen ion, that is dissociation constant of water, equals to the product of hydrogen ion and hydroxide ion. And from there, we can work out the amount of hydrogen. A buffer solution prepared by mixing 20 cm cube. So we made a buffer solution. What is a buffer solution? A solution which resists the change in pH. That's called a buffer solution. So a buffer solution is prepared by mixing 20 cm cube of 0.1 mole per dm cube methanoic acid with 10 cm cube and 0.1 mole sodium hydroxide. The dissociation constant of methanoic acid is given. So first what happened, the methanoic acid reacted with sodium hydroxide. So when they react with each other, it will form sodium methanoic. I draw ethanoic acid instead of methanoic. Methanoic acid is there, so that is HCOH. Reacted with sodium hydroxide, NaOH. As a result, it will produce sodium methanoate plus water. So 20 cm cube, 0.1 mole per dm cube methanoic acid. So it will be 20 divided by 1000, which is 0.02, and that is multiplied by 0.1, which makes 0.002. 0.002. And hydrochloric acid moles, these are the moles. The sodium hydroxide moles, that is 10, the volume is there, divided by 1000 to convert it to dm cube, and then multiplied by 0.1, which makes 0.001. So this will be 0.001. But when the reaction occurs as sodium hydroxide, you can see ratio is 1:1. So sodium hydroxide is a limiting reagent, so it will be used up. As it is used up, how many moles are left for acid? 0.001, because 1:1 ratio, this many reacted. So left is 0.002 minus 0.001, which is 0.001. And same thing, the form moles of the salt, that is also 0.001. So simple way. Now, when we mix them, now we need a concentration, a new concentration, because we mix them together. We mixed 20 cm cube with 10 cm cube, so the volume is 30, which is 0. So 30 cm cube is there, which is 0.003. So 0.001 divided by 0.03, that makes 0.003 is there. And 0.001 divided by 0.03, that's also make the same. 0.03. So basically, this question, what happened when it shows that it can be solved in a very short method, but like first I'm explaining the idea how it can be done, but and then I'll explain the trick how you can use that trick to quickly get the answer. So means we have the same concentration of the salt and acid and its salt. Now what we'll do, we'll write a dissociation constant Ka. So dissociation constant is the acid, like the product, which is in this case it is HCOH, HCO and H divided by the concentration of HCOH. Because these are the same concentration, so they cancel out each other. So we can say Ka is equals to H, or we can also say pKa is equals to pH. So pKa will be equal to pH. So if pKa is 3.8, what should be the pH? So pH should also be 3.8. So basically, how it can be done instead of using this long method, if this is called a half equivalence point. Whenever a half equivalence point is there, half equivalence point means like half of the acid is used up and the amount of the acid is same as the amount of the salt produced. So you can see 20 cm cube 0.1 and 10 cm cube 0.1. So means when we react with each other, we are left with 10 cm cube of a salt, or the half of the salt and the acid. So as a result, whenever at a half equivalence point, the pK dissociation constant will always be equal to hydrogen ion concentration. So if pK is 3.8, the hydrogen ion concentration will also be 3.8. If the pKa is 3.8, the pH will also be 3.8. The hydrogen ion concentration we can find by using NT law. So the idea is when half of the acid is used up completely and we'll have a same amount of a salt present, that time pKa is always equals to pH of a solution. Is it clear, this one? Then in question 23, the calibration of a pH meter is best carried out using. So if you want to calibrate a pH meter, how it should be done? So solution of an alkaline buffer and acid, because buffer solutions will have a constant pH, it won't change the pH. Maybe strong acid might have a pH 1, might have a pH 1.2. We are not sure. So if we use a strong alkaline buffer or acidic buffer, then we can easily identify the or calibrate the pH meter. That's why A should be the right answer. Why not strong acid, strong alkali, or weak acid or weak alkali? Even if the acid is strong, but it may have a pH 0, it may have a pH 1, pH 2. And same thing, if it's a strong base, it may have a pH 13 or 14. So there is a range. But for buffer solutions, there is no range, like it resists the pH, so pH will be constant. Buffer solutions are vital in maintaining the relative stable pH in a human body. One of these is a carbonic acid hydrogen carbonate buffer. Given the formula above, calculate the pH at 38 degrees centigrade. When pK is there, hydrogen ion concentration. So the formula is given, the pKa, we just substitute, like this is 6.1. The amount of hydrogen carbonate is there, and H2CO3 concentration we just substitute and get the final result, which is 7.15. So D will be the right answer. Then the carbonic acid is formed by dissolving a carbon dioxide in water. If the carbon dioxide, if this equilibrium is present, if the carbon dioxide is removed, the equilibrium mixture, the pH will. So what will happen to this pH? If amount of carbon dioxide we remove, the equilibrium will shift toward the left hand side. So as the equilibrium will lift, shifting towards the left hand side, you can see the first part H2CO3. So as I mentioned, if the carbon dioxide is removed from this equilibrium mixture, so the carbon dioxide is removed from the equilibrium mixture, the amount of H2CO3 molecule because it will try to shift towards the left hand side. So amount of H2CO3 molecule will decrease. As the amount of H2CO3 molecule will decrease, like because this H2CO3 molecule are responsible for giving proton. So if amount of H2CO3 molecule will decrease, there will be like this equilibrium will shift towards the back hand side, or hydrogen ion concentration will decrease. So if the hydrogen ion concentration decrease, what happened to the pH? The pH will increase. So when we reduce carbon dioxide, equilibrium shift towards left hand side. If amount of H2CO3 decreases, more hydrogen and carbonate ion combine to give this H2CO3. So amount of hydrogen decrease, that's why the pH will increase. As there's an inverse relation between pH and the hydrogen ion concentration.